Hello everyone, and welcome back to another video. So I'm Michael, and I'll be explaining problem number 3 on the Washington Gold HMMT PUMaC team selection test. So the problem goes as follows. So we have Hong here. Hong picks 3 real numbers, a, b, c, such that b squared plus c squared is equal to 2021 times a, c squared plus a squared equals 2021 times b, and a squared plus b squared equals 2021 times c. And we'd like to know the sum of all possible values of a. And at first sight, these equations look pretty nasty, right? Like we have squares on the left-hand side, we have all 3 variables in all 3 of the equations. Substitution doesn't look directly feasible because then we'd have like b to the 4 and b to the 8 and stuff like that floating around if we tried to substitute. So we're kind of stuck in directly figuring out anything about these 3 variables. But one thing we do notice is that these 3 equations, they have a weird symmetry to them, right? Like we have b squared plus c squared, we have c squared plus a squared plus b squared on the left-hand sides. And on the right-hand sides, we have 2021a, 2021b, and 2021c. And there's almost this type of anti-symmetry among these 3 equations, and then when we see something like this, it's probably in our best interests to take advantage of it somehow. So when we think about how we can take advantage of this, one thing that should come to mind is, say, adding or subtracting pairs of these equations. And when we think about it, right, we have squares on the left-hand side. And when we subtract squares, we get differences of squares, which can be factored. So, motivated by this, let's try subtracting the first pair of equations. So let's subtract the first pair of equations. So what do we get here? We get b squared plus c squared minus c squared plus a squared equals 2021a minus 2021 times b. So we can just expand this out. B squared plus c squared minus c squared minus a squared equals 2021. I'll factor the 2021 here, so 2021 times a minus b. And look at that, our c squareds cancel out. So I get b squared minus a squared is equal to 2021 times a minus b, and now the way forward is clear. We can factor the difference of squares just like we planned. We have that it is equal to 2021 times a minus b. And right here, we should be really happy because we notice that we have an a minus b here and a b minus a here. So that means if a is not equal to b, we can cancel this out to just get a plus b equals negative 2021. But let's look back at our 3 original equations. We're given that a, b, and c are real. But what does this mean? Since a, b, and c are real, b squared is non-negative and c squared is non-negative. But since b squared plus c squared equals 2021 times a, that also means a is non-negative. And similarly, b and c are all non-negative. So we actually have the a, b, and c are all greater than or equal to 0. So that means this equation, a plus b equals negative 2021. That means this is untrue. So that means our assumption that a is not equal to b is false. This scenario just cannot happen at all. Which means, in fact, that we can't divide by b minus a in these 2 equations, which means that b minus a equals 0, so a equals b. This is great. This is great because we can do the similar things for the other 2 pairs of equations. So from the first 2 equations, we just got a equals b, and similarly, we can get that b equals c and c equals a. And these 3 equations together tell us that a equals b equals c. So this is really good. This is really, really good. We're almost done now. So let's box off some space to give us some space to work with. And we now know that A equals B equals C. But let's look at what the first equation said. We have B squared plus C squared equals 2021 times A. C squared equals 2021 times A. So that means since B equals C equals A, we have A squared plus A squared equals 2021 times A. So 2A squared equals 2021 times A. And now we can just easily solve this quadratic to get that A is either equal to 0 or A is equal to 2021 divided by 2. And these are our only two possible values for A. And the sum of them is obviously 2021 over 2. So that's our answer, and we are done.